Determine the components of reaction at the support A and B on the rod. So with this problem, unlike most problems that are given with numeric quantities, this is only given in quantity in terms of constants. I guess you call them variables, but for this instance, it's a statics problem, so these will all be constants. There's some number, some real number, and we do not know these constants, but we're still able to solve this problem. Even with instead of our answer being a number, it's going to be in terms of these constants. So these are all givens. So let's write them down so we know what is a given, what we can use in a problem. So we're given length L, a force P, and that is it, I guess. So let's start with our find variable. We're looking for all the reactions acting on this beam right here. So the reaction at A here is going to be a vertical roller. So it's going to be creating two different reactions. It's going to be creating a reaction in the x direction, which would be AX, and it's going to be resisting moments too. So moments about A. And B is your standard roller, and it'll only be resisting forces in the y direction. Okay, so we can start with our free body diagram. Okay, so drawing the beam like this. Even though this is kind of in the reaction here, this part of the beam is still part of it. It's still part of the system that we're looking at here. So nice long beam here. As we go from left to right, let's label our points. We have A here, B over here, and we have L over 2 and L over 2. Okay, so the reaction here at A, like I said, is going to be a reaction in the x direction here. And it's also going to resist moments, which we can define like this. That's going to be AX and then moment about A. Okay, but will not resist any forces in the y direction. Moving on to the middle, we have force P acting on the beam. Okay, and that's going to be a vertically acting vector. There's no horizontal components acting there. And that B right here, we can have the reaction By. Okay? So now moving on to equations of equilibrium. Should also specify that equilibrium, that this is a weightless, massless, widthless, rigid beam. So there's a couple assumptions we should take into account when solving this problem. So let's start with summing the forces in the x, setting equal to 0 because the beam isn't moving. We have one force acting in the x direction, AX, and set the equation equal to 0, and then we get our first find variable, AX. And if you get only one force acting in a certain direction and it's a statics problem, you know that force is going to be 0. And there's really no force acting in the x direction. This reaction here, x, really doesn't exist. But that first one's going to be 0. Okay? So now we're going to move on to summing the forces in the y. So that equal to 0 because this beam's at rest. First force is going to be P. To be acting in the negative direction for that. The only other force acting in the y is going to be y. Set that equal to 0. We're going to get that By is equal to P. And we know that P is one of our givens right here. So we can have our final answer be in terms of that P. So that's going to be simply P. Okay? And the moment about A is going to be the last one. And we know that moments are a force times a distance. A force times a moment arm. So we know that our answer would be in terms of both P and Y, and P and L for this. So I have the sum of forces. Actually, let's sum the forces around B here. So we have the By cancel out. okay? If we sum the forces here, this By is going to create no moment, and it'll only be P creating a moment about here. But if we sum the moments here, we're going to have By and P creating a moment. So this will be a little easier for us. So we have the reaction at A. So we have first moment, or reaction at A right there. And then, since this is a free moment, there's no need to multiply by any moment arm or anything like that, because it is just a pure torque, a pure turn of the beam. There's no force acting left, right, up, down, anything like that. And because this is because we denoted it kind of as a clockwise vector, we'll be giving it a negative notation. Okay. And P right here is going to be your force. It's going to be acting in positive direction, so we know it's going to be P. And then the moment arm is going to be L over 2 right here. So equal to 0, we're going to get MA is equal to PL over 2. Okay. As we can see, like I mentioned earlier, since we know moments are going to be in terms of a force times a distance, we have our force P here, and we have our distance L. So we know that we have the right units, the right dimensions, I should say, for this answer. That should be our final answer, PL over 2. Found all the find variables, and we're done.